Welcome back. Alright, so in the last video we looked at doing some angle bisector problems and some perpendicular problems. We have to remember that upside down T means perpendicular. Now let's talk about linear pair. To define a linear pair, we know it is a pair of adjacent supplementary angles. Okay, then it says to sketch an example. It's a linear pair, which means it looks like a line on one side, and then there's a ray. So I've got one angle and a second angle because it's a pair of angles. A pair is two angles, okay, that are adjacent, right? They share this vertex, they share this side, they don't overlap, and they're supplementary. They add up to 180. Okay, they have to be adjacent to each other. They can't be split like just plain old supplementary angles. Okay. All right, my next question says identify all sets of linear pairs in the diagram below. So when I look at this, I've got angles 1 and angle 2. Make a line. But I could also say angle 2 and angle 3. But I could also say angle 3 and angle 4, make a line. And lastly, I could also say angle 1 and angle 4, make a line. And then if I just rotate one more time, then I'm back to angle 1 and angle 2. Okay, so when two lines intersect, you really have four pairs of linear pairs, if that makes sense. Okay? All right, number 15, identify all sets of linear pairs in the diagram below. So I'm going to use my paper and do the same thing I did on the last one. So if I come here and I put along this line, okay, I can see that it takes 3 angles to make this line. So that's not a pair, right? That's like a trio. So I'm looking for a pair of angles, so just 2 angles. So I can't use A, B, and C. So then I'm going to rotate to this line, and I have the same problem, right? B, C, and D, it takes 3 angles to make that line. So I'm going to rotate around. Now this is not a line, right? Because it doesn't keep going underneath there. All right, so then I keep rotating. Oh, look. E and D are 2 angles that make a line. So I can say angle E and angle D. Okay, and then if I rotate again, look here, angle A and angle E make a line. So I can use, let's see if I can slide up a little bit so I'm more centered, angle A and angle E. Okay, and then if I were to keep rotating, then I'm back to that ray, which doesn't help me, and then I'm back to ABC, which is 3 angles, so that doesn't work. Okay, so linear pairs, 2 angles that are adjacent that make a line, so their sum would be 180. Okay, let's look at the next page. Define vertical angles. Vertical angles, a little bit different. So for vertical angles, those are angles across from each other when 2 lines intersect. Okay, so since the next problem is talking about vertical angles, I'm just going to sketch myself a picture so I can remember that. So vertical angles are going to be here and here, or we could say the top and the bottoms. Okay? All right, so the next section is saying, are the following statements about vertical angles always, sometimes, or never true? Okay? Vertical angles, the first one says they are adjacent. Well, they're always going to share a vertex, which is required for vertical angles, but the vertical angles are never going to be able to share a side, which means they can never be adjacent. Okay, they can't share a side. The next one says they are complementary. Remember, that means they add up to 90 degrees. So if I could draw lines that intersect where I had a 45-degree angle here and a 45-degree angle here, then they would be complementary. So that can sometimes be true, but it doesn't have to be true, because then this top and bottom angle, they wouldn't be 90, right? If these were both 45, then these could not be 45. So sometimes they're complementary, but not always. Okay? They are congruent. That is the vertical angle postulate. Vertical angle postulate tells me that yes, these angles are always the same. If this one's 45, this one's 45. If this one's 80, this one's 80, right? So yes, that is always true. They are supplementary. Well, we know they can be complementary, but they don't have to be, which means, notice if they're complementary, they're not going to be supplementary. But can they sometimes be supplementary? Think about when you graphed in Algebra 1 and Algebra 2, right? You graphed on an XY axis where your angles were 90. Oh, look at those two vertical angles. They're both 90. So they can be supplementary. 90 plus 90 is 180. But they don't have to be, so that's a sometimes. And they are non-adjacent. Well, if they are never adjacent, right, then that means they are always non-adjacent. Okay? All right, let's look at number 18. Name the angle that is vertical to angle BAS. So, well, let's first find out where angle BAS is. BAS. Okay? So that's the angle I want to be vertical to. And so I need to figure out which one is across from that when my two lines intersect. So I need to look at two intersecting lines. I'll zoom in so we can see a little better. Okay. All right, so it's when two lines intersect. So if I were to take this ray and think of it as a line, and then I took the ray of this angle, this other ray, and thought of it as a line, then that shows me where the vertical angle is. I just have to know what to call it. I know it has a vertex of A, and then on either side it has an E and it has an L. So I can call it angle EAL. Capital E, capital A, capital L. The A has to be in the center, but I could call it LAE or EAL, as long as the A is in the center and the E and the L's are around it. Okay? Number 19, name two angles adjacent to EAG. So let's see where E, A, and G are. E, A, G is this angle right here. So I want to name two angles. There are more answers than the ones I'm going to give you. Just for your information, if you got something different than I get, it doesn't necessarily mean it's wrong. Okay? Two angles that are adjacent, so that means it has to share a ray. So let's say I wanted to share this ray. Okay? It has to share the vertex, and then it can't overlap, so it can't go this direction. It has to go this direction. So I could look at this angle here, or I could look at that whole straight angle, right? Or even I could keep going and do like reflex angles. So I'm just going to do the simple one right next door. Angle BAE, or I could call it EAB, as long as the A is in the center. So angle BAE, but it did ask me for two adjacent angles to that red angle, so I'm just going to find the other one on the other side. I'm going to use this ray, and I'm just going to choose the other angle on the other side of it. That's the other adjacent angle to this red one, right? Both of these are next to the red one. So angle GAL or LAG, whichever you want to call it, as long as the A is in the middle and the G and the L are surrounding it. Okay? Let's do these last two, and then we will save one more page for the last video. Okay? Name two angles supplementary to angle BAE. So BAE, here we go, is this angle here. Supplementary means they add up to 180. If I don't have numbers, the only way I know that two angles are supplementary is if they are a linear pair, meaning they make a line. So if I were to extend one of the rays into a line, and then I looked and saw what angle makes me complete the side for that line, it would be angle BAS or SAB. You could call it either one, angle BAS or SAB. It did ask me to do two though, right? So to find the other one, I'm going to do the same thing, but instead of with this ray, I'm going to do it with this one. I'm going to extend this one to a line. So then I'm just going to look at the underside of that. What's left is going to be this piece to make this whole line, which is, it still has the A and it goes out to E and it goes out to L. So angle EAL, or I could have done LAE. The A has to be in the center. Okay. All right, one more. If the measure of angle BAE equals 2x plus 25 and the measure of angle SAL equals 3x minus 10, find the measure of angle BAE. So let's see where those angles are so we know what to do with them. BAE is 2x plus 25. And the measure of angle SAL is 3x minus 10. I want to find the measure of angle BAE. So I want to find the pink angle, BAE. Well, those two are vertical angles, and my vertical angle postulate says that means that the 2x plus 25 and the 3x minus 10, my vertical angle postulate allows me to say that these two angles are equal. Okay, so now this I can solve. I'm going to subtract 2x on both sides. 0 plus 25 equals x minus 10. Add 10 to both sides. 35 equals x. So my question was, how big is BAE, the pink angle? So the pink angle, 2 times 35, because that's x, plus 25, is 70 plus 25. So it is, I know it doesn't look like it's obtuse, but it is 95 degrees. Okay? If I were to check the other side, just to check to see if I did my math right, because I go, well, that doesn't look obtuse, I'm going to check it. So I'm going to do 3 times 35 minus 10. 3 times 35 is 105. And 105 minus 10 is 95. So it does work out. My answer is that angle is 95 degrees. Okay? All right, on the next video, we're going to start looking at complementary and supplementary angles. Okay, complementary and supplementary angles. Thank you so much for watching.